Hello my friends, and welcome back to the You Can Do TV channel, where the geometry of the spring is shaped through chipless deformation. Compression and tension springs are formed by a coiling process, while torsion springs are created by winding the wire around a mandrel. Spring-hard wire is fed into coiling rods via feeder rollers, and an inclination rod pushes the wire out to form the spring. Adjustable positioning allows for various spring shapes. After shaping, a rotational cut produces burr-free spring ends. The facility uses over 50 advanced coiling machines for wire diameters, ranging from 0.3 mm to 16 mm. Next, thermal treatment, tempering or annealing, removes internal stresses from plastic deformation. Precise temperature control ensures consistent quality. For compression springs, end coils are ground flat to improve axial compression. This is done using over 25 CNC grinding machines, with cooling and extraction systems to maintain surface quality and precision. To improve fatigue strength, shot peening is applied. Springs are blasted with rounded cut wire shot to induce surface compressive stress and strain hardening, improving durability. Plasticizing or presetting maximizes material performance and prevents setting loss, increasing the load-bearing capacity of the spring. Warm and cold setting machines are used for different customer requirements. Finally, surface processing protects springs from corrosion using coatings such as epoxy, polyester, dacrymet, delta, or galvanic treatments. Quality assurance is integral to every stage of production. Our facility implements strict inspections, continuous monitoring, and automated measurement systems to ensure dimensional accuracy, mechanical performance, and surface integrity. All processes comply with international standards, guaranteeing high-quality, reliable springs for demanding applications. High-performance drive chains play an important role in industrial machinery and vehicles. Manufacturing these chains involves a tightly controlled process focused on precision, strength, and long-lasting durability. Production begins with high-grade steel, which is processed into components such as pins, bushings, rollers, and link plates. These parts are stamped or machined in-house to ensure maximum quality control. After forming, all components undergo heat treatment to improve hardness and wear resistance, followed by shot peening or similar surface treatments to enhance fatigue strength. To ensure smooth operation, components are deburred and polished through vibratory finishing. The chains are then assembled using automated systems for consistency and accuracy. Pre-stretching is applied to reduce initial elongation, and each chain is lubricated with high-performance grease suited for demanding conditions. These chains are tested for strength, flexibility, and performance before leaving the factory. Thanks to their reliability, they are used by leading manufacturers across industries such as automotive, agriculture, packaging, and heavy machinery. Known for transforming tradition into innovation, top-tier producers of drive chains are trusted worldwide, where motion and power must be transferred efficiently. P&T conducted a test lifting a fully equipped car using two standard speed feeder 130 units to demonstrate their automation system's strength and reliability. Despite nearly 700 kilograms of load on one feeder, the system handled it with ease, proving its durability, intuitive logos control, and suitability for demanding sheet metal handling applications. The forging industry is a vital pillar of manufacturing, delivering precision-engineered components for automotive and beyond. Cold forging crafts high-strength parts like two-wheeler magneto boss centers and front fork bottom bridges, while UJ cross forgings highlight its versatility. Hot forging produces durable components such as midship tube shafts for four-wheelers and starter motor parts, ensuring robustness under stress. The process begins with cold forging for intricate, resilient small parts, followed by hot forging for larger, tougher pieces, and cold forming to refine precision. Advanced techniques like machining, gear hobbing, and broaching shape components, while induction hardening enhances durability and shot blasting perfect surfaces. Tool rooms support bespoke tooling, driving innovation. Quality defines the industry, enforced through eddy current testing, temperature monitoring, and stringent multi-stage checks. Testing facilities ensure defect-free products, meeting exacting standards. Blending cold and hot forging with cutting-edge processes. The forging industry supplies reliable, high-performance parts for 2- and 4-wheeler applications. It meets automotive demands with unmatched craftsmanship, supporting global markets with strength, consistency, and efficiency, and continually evolving to address modern engineering challenges. The manufacturing of carbon composite cylinders begins with plate-to-cup drawing, where high-strength metal plates are formed into cylindrical cup shapes. These shells are thoroughly washed to remove any contaminants before moving on to inspection to ensure material quality. Next, the liner spinning process shapes the interior of the cylinder, followed by heat treatment to enhance mechanical properties. A machine port is then added for gas inlet/outlet, and the liner is carefully inspected for structural integrity. Afterward, the cylinder is wrapped with carbon fiber for added strength while minimizing weight. Labels are applied to identify and trace each unit. The cylinder then undergoes curing to solidify the composite structure, followed by sanding to create a smooth finish. To guarantee leak-proof performance, each cylinder is subjected to hydrotesting under high pressure. For UV protection, a UV gel coating is applied, preserving the cylinder surface against environmental damage. Finally, a comprehensive inspection ensures each product meets the highest safety and quality standards before shipment. This multi-stage process results in lightweight, high-strength carbon composite cylinders used across various demanding industries. The deep groove ball bearing production line is a highly automated and precise process that begins with grinding, where the inner and outer ring processes are seamlessly linked through automated systems. The inner ring grinding process shapes the groove, followed by the outer ring grinding process to achieve perfect concentricity and smoothness. The components are then transferred to the automated assembly line, where the inner and outer diameters are meticulously inspected for accuracy, followed by a cleaning process to remove debris. Grading and matching ensure compatibility between components, and the cage is installed and securely riveted to hold the steel balls. The finished bearing is thoroughly cleaned, followed by advanced imaging of the steel balls and cage for defects. Flexibility and clearance are tested to confirm smooth rotation, while noise levels are evaluated using a BVT to ensure quiet operation. The bearing is then dry spun, greased on both sides, and fitted with double-sided seals via press fitting. Grease is evenly distributed to enhance durability, and an automatic appearance test checks for surface flaws, supplemented by a manual review. Finally, an anti-rust coating is applied before packaging and loading, ensuring the bearings are ready for global distribution with top-tier performance and reliability. Indispensable in modern industry, used by most automotive manufacturers and in a variety of industries such as food processing and mechanical engineering. These chains are forged from high-grade alloy steel and are manufactured through a sophisticated manufacturing process. The process begins with precision CNC machining to shape components such as rollers, pins and bushings to micron-level precision, followed by advanced heat treatment, quenching and tempering to increase hardness and resilience. Automated assembly lines then seamlessly join each component, ensuring a perfect, consistent fit. The process incorporates rigorous quality control measures, including laser-measured tooth pitch accuracy and ultimate tensile testing, in compliance with global standards such as ISO and ASI. Pioneering brands like IS upped the game with innovations like sintered bushings and lifetime lubrication, delivering frictionless, maintenance-free operation. The lotion pump assembly machine is a cutting-edge automated system engineered for high-speed production, assembling 110 to 120 pumps per minute with remarkable precision. It starts with a vibratory feeding system, delivering components, pistons, stems, housings, springs, and gaskets to a rotary assembly line. The process involves pressing the piston and stem together, followed by integrating gaskets and springs into the housing, often lubricated with silicone oil for seamless function. Advanced rotary towers and smart controls ensure accurate alignment and real-time monitoring, while an air tightness test confirms quality. The actuator is then fitted, and dip tubes are precisely inserted using adjustable mechanisms. This high-output machine minimizes manual labor, enhances consistency, and meets rigorous standards, making it a vital asset for large-scale manufacturing in the cosmetics and personal care industries globally. Northern Iron and Machine utilizes an advanced Osborn automated tight flask molding machine for efficient iron casting, capable of producing up to 38 molds per hour for castings up to 250 pounds. The system allows for quick pattern changes within 60 to 90 seconds and simplifies the setting of chills and sleeves. Its unique compensating squeeze head ensures even mold hardness, enabling the casting of parts with complex geometries. The machine also features quick vent drilling to relieve gas buildup and precise core placement during the mold cycle. Cope and drag halves are automatically combined and sent to the pouring line. The iron pourer checks and maintains the correct iron temperature, adds alloy as specified, and ensures consistent mold weight. This automated process guarantees high-quality ductile, gray, and os-tempered iron castings with optional machining, plating, painting, and assembly services. HAITIMA ball valve manufacturer is a leading global valve producer specializing in high-performance industrial valves. Their product range includes 2PC and 3PC screwed end ball valves rated up to 6000 WOGPN 420, featuring API 607 fire-safe approval, ASMEB 16.34 wall thickness, NACE MRO 175, and TA Luft certification. Additional products include Y strainers, blind flange valves, control valves, HPFA-lined and cryogenic valves, actuators, sanitary components, and high-pressure API 6A16C gate valves through their sister company HUIVER. They also supply pipe and forge fittings via Tomo Forge Fittings, adhering to ASME B 16.11. HAITIMA emphasizes continuous R&D, strict quality control, and advanced manufacturing processes, including wax injection, shell burning, casting, and heat treatment. The angle grinder manufacturing process is a sophisticated process that combines advanced technology with skilled craftsmanship to create the tools. It begins with the design phase, where engineers use CAD software to optimize compact structures, high power output, and long-lasting durability. Once the design is finalized, raw materials such as high-grade alloy steels and engineering plastics are sourced. The machining phase begins with CNC machines, precisely cutting components such as housings, gears, and motor shafts, achieving tolerances within microns for perfect fit and performance. Next, the motor, the heart of the grinder, is built. Copper wire is wound into coils using an automated system, then assembled with the rotor and stator, meticulously balanced to minimize vibration. Heat treatment follows, hardening metal parts like gears to enhance strength and load-bearing capacity. The components then move to the assembly line, which may be automated or manual depending on the manufacturer. At Fane, for instance, a single technician often assembles each grinder entirely, fitting the motor, gearbox, and protective guard, ensuring consistent quality and a personal touch. Lubrication is applied to reduce friction, followed by performance testing in a run-in chamber, where the grinder operates continuously to evaluate durability, noise levels, and material removal efficiency. The final step involves rigorous zero-tolerance quality checks, testing every detail from power output to safety features, ensuring compliance with international standards. Only then is the angle grinder packaged, ready to deliver top-tier performance to industrial and trade applications worldwide. In the industrial valve manufacturing sector, machining automatic special machines, valve rod special machines, PTFE seal ring special machines, and full automatic assembly lines play a crucial role in enhancing quality and efficiency. The machining automatic special machines are built on manipulator systems supported by servo motors, carrying out two processes using profile cutters. This ensures critical dimensional accuracy and uniformity, transforming rough or semi-finished products into high-quality components with quadruple productivity. Type B automatic special machines form critical dimensions in a one-step process, replacing traditional three-step procedures. This reduces clamping and transfer errors, avoids misalignment and damage, and subtly increases product lifespan. Equipped with diamond cutting bits, these machines achieve a surface smoothness of RAS 0.8, guaranteeing no leakage even after 10,000 uses, enhancing both product quality and reducing labor. Valve rod special machines imported from Taiwan address traditional issues such as low efficiency and high error rates. Through equipment upgrades and process integration, these machines improve quality control across all stages, from copper bars to final valve parts. For PTFE seal rings, extrusion molding is conducted in a single automatic step. Raw materials are sourced from reliable manufacturers at premium cost to ensure consistent input quality. This in-house production prevents outsourcing, reduces waste, and creates durable, smooth, and ergonomic products with strong wear resistance. The full automatic assembly line, imported from Italy, the homeland of valves, uses infrared inspection and operates in spacious workshops. The entire assembly process is handled by a single worker, replacing up to 13 workers on traditional lines. This reflects the seamless coordination between humans and machines, enabling precise, efficient, and high-capacity production, while maintaining product consistency and reducing costs. An iron foundry is a powerhouse of industrial craftsmanship, transforming raw iron into precision cast components for diverse applications. Operating since the industrial era, a modern iron foundry like Benton Foundry in North America exemplifies longevity and innovation. With roots tracing back to the mid-1800s, it specializes in gray iron, ductile iron, and tempered ductile iron, producing items such as pumps, valves, and manifolds. The process begins with melting iron in advanced furnaces, followed by pouring into molds crafted on automated lines, 93% of which are made using cutting-edge molding machines. Robotic grinding and core-making equipment enhance precision, while order volumes range from 25 to 10,000 molds, weighing 1 to 250 pounds. Beyond casting, the foundry integrates engineering design, heat treating, machining, and packaging, offering a seamless, cost-effective solution. Committed to sustainability, it eliminates smokestacks and water discharge, employing energy-saving techniques like optimized airflow systems, slashing costs and emissions. This clean, safe environment ensures high-quality output, certified by ISO standards. By blending mass production efficiency with moderate volume flexibility, the iron foundry meets modern demands, delivering durability and punctuality to industries worldwide while setting a green benchmark for the future of metal casting. At Waka Foundry, pride is a fusion of metallurgical science and manufacturing artistry, crafting high-quality gray and ductile iron castings. With a legacy spanning generations, this foundry produces more iron than many nations, pouring castings from 2 to 350 pounds with unmatched precision. The process marries innovation with tradition. Custom-built vertical green sand molding machines ensure consistency, while automated core making and finishing systems minimize machining needs, cutting costs. Advanced 3D pouring simulations perfect each mold fill, digital imaging verifies casting integrity, and rigorous testing upholds quality. Metallurgical expertise identifies and resolves potential flaws early, blending seamlessly with the artistry of skilled workers who shape every piece. Lean manufacturing drives efficiency, reducing waste and enhancing value, while 6 US-based facilities tackle the toughest jobs. Waka Foundry also champions sustainability with eco-friendly initiatives and safe work environments. This synergy of cutting-edge technology, passionate craftsmanship, and environmental stewardship delivers reliable, cost-competitive castings, setting an industry benchmark for excellence and dependability. Edelstahl Rosswerk, a renowned European forge, has crafted a new clapper for Austria's largest bell, the Pommerin, at St. Stephen's Cathedral in Vienna. Forged from a 1-ton steel block, the clapper was shaped through intensive free-form forging, ultrasonic testing, and heat treatment, resulting in a final weight of 580 kilograms. Made from RSK 100, a special alloy developed by Robotics, it withstands extreme temperature changes from minus 30 degrees Celsius to plus 40 degrees Celsius. The lighter weight ensures a softer strike, protecting the bell while maintaining its iconic sound. Known for supplying clappers to many major churches across Europe, Robotics donated this piece, along with material and planning support from Austrian partners, to the cathedral community, a gift of craftsmanship, tradition, and cultural significance. Manufacturing a hot-formed boiler dome for an on-site installation was a complex challenge met by Antonius with precision and expertise. With a tight 6-month deadline, the goal was to use minimal material while ensuring structural integrity. Antonius designed custom press molds to shape the dome in a single hot pressing cycle, avoiding time-consuming rework. Dimensional accuracy was critical. A 1% deviation on a 10-meter structure could lead to several centimeters of error, exceeding tolerance limits. To guarantee results, a test assembly was conducted, and multiple advanced welding techniques were used for strength and reliability. Beyond manufacturing, the team overcame logistical, spatial, and environmental challenges, as the metal's properties are sensitive to temperature variations. With over 10,000 man-hours invested, Antonius successfully delivered a massive, highly accurate structure, installed on time and on location. This project exemplifies high-end craftsmanship in the digital age, where precision engineering meets bold execution, shaping the impossible. China is a dominant force in the global pump and valve casting industry, serving key sectors such as water treatment, oil and gas, chemical processing, and power generation. With its extensive manufacturing capacity and technological advancements, China contributes significantly to the international supply of cast components. By 2024, China's annual output of pump and valve castings has surpassed 1.8 million tons, making up over 25% of the global total. Major production hubs are concentrated in Hebei, Shandong, Jiangsu, and Zhejiang provinces, where a large number of foundries specialize in various casting methods, including sand casting, investment casting, and shell molding. The materials commonly used in production include ductile iron, stainless steel, carbon steel, and bronze, tailored for different operational environments. High-performance alloys and stainless steel are increasingly utilized for demanding conditions, such as corrosive or high-temperature applications. Technological innovation is transforming the sector, with many foundries implementing 3D modeling, simulation software, and automated mold-making systems. These upgrades have improved casting accuracy, shortened development cycles, and reduced waste. In 2023, China's export value of pump and valve castings exceeded $2.4 billion United States dollars, with top destinations including the United States, Europe, and the Middle East. As global demand for reliable and efficient flow control components rises, Chinese manufacturers are investing in quality control systems, ISO, APICE certifications, and environmentally friendly production practices. Despite challenges such as tightening environmental regulations and rising labor costs, the Chinese pump and valve casting industry is projected to grow at a CAGR of 4.5% through 2028, maintaining its strategic importance in the global industrial supply chain. The SIMPAC tandem press line, featuring the DE and DTE eccentric press series, is a mechanical forming press tailored for automotive applications. With a pressing force ranging from 300 to 3,375 tons, it handles medium to large-sized components. Its slide kinematics, driven mechanically, excel in operations like cutting, stamping, bending, punching, embossing, and forming. This versatility makes it a cornerstone for producing high-quality automotive parts, from small, intricate pieces to larger structural elements. The mechanical drive system of the DE and DTE series delivers a sinusoidal slide motion curve, ideal for flat and semi-flat parts. This design ensures precision and consistency, critical for automotive manufacturing. The press line can operate as a standalone progressive or transfer press, or as a fully automated tandem system, adapting to diverse production needs. Whether shaping small brackets or larger panels, its robust configuration supports high volume output while maintaining tight tolerances, meeting the automotive industry's stringent standards. The company's proven technology, continuously optimized over years, guarantees a reliable production process. The DE and DTE mechanical drive excels in cutting, punching, bending, and stamping, offering flexibility across applications. The press body, crafted with low-stress annealing and calculated via finite element method, is reinforced at hotspot zones to withstand high loads. Its tie rod design connects the rigid frame with hydraulically pre-stressed rods, enhancing stability. Off-center pressure points and an 8-fold slide guidance system absorb eccentric loads, reserve forces, and die stresses, ensuring uniform part quality. An automated centralized lubrication system boosts productivity and uptime by reducing wear and maintenance downtime. Optional features like die cushions, pneumatic ejectors, or moving bolsters accelerate die changes, further enhancing efficiency. These attributes make the press line a powerhouse for small part production, delivering consistent results under demanding conditions. In the automotive sector, this eccentric press line shines for small parts like brackets, clips, and connectors, as well as medium to large components such as chassis reinforcements. Its ability to integrate into automated workflows aligns with modern lean manufacturing, reducing costs and lead times. With a focus on durability, precision, and adaptability, the tandem press line stands as an ideal solution for automotive manufacturers seeking quality and efficiency in high-stakes production environments. The crossbar robot represents a cutting-edge solution in injection molding line automation. Designed to streamline forming operations, it supports multiple unloading options using either a suspended or standard robot, ensuring seamless part handling. At the heart of its performance is an 8-axis robot capable of handling a maximum combined payload of 90 kilograms, including part and tooling. With an output capacity of up to 15 strokes per minute, the crossbar robot achieves impressive productivity levels. The system is optimized for press distances of 5 to 10 meters, 197 to 394 inches, providing adaptable installation across a variety of plant layouts. Key features such as automatic tool changeover and flexible part orientation from die to die enable easy transitions between different production needs. Additionally, the crossbar robot supports both double and quad part production, further enhancing throughput and operational flexibility. The system is part of a comprehensive offering that includes automation solutions, software, tooling, process know-how, and services tailored for the entire sheet metal forming industry. Our customers include leading automotive manufacturers and suppliers, as well as companies in the forging, home appliance, and electronics industries. With this broad and integrated approach, the crossbar robot not only boosts efficiency, but also provides end-to-end support for sustainable and future-proof metal forming production. A pipe straightening machine is used to correct the curvature and distortion of metal pipes, ensuring straightness and uniformity. It operates with multiple rollers applying pressure to reshape the pipe. This equipment enhances pipe quality, improves precision in downstream processing, and increases overall manufacturing efficiency. The production process of Alora wrenches in Germany starts from the design stage, where each wrench is meticulously planned using advanced CAD software to create precise technical drawings. These designs serve as the blueprint for the entire manufacturing process. The next step is hot forging, where high-grade chrome vanadium steel is heated and pressed into the rough shape of the wrench. After forging, excess material, burrs, is removed, followed by manual grinding to smooth the surfaces and refine the shape. The open and ring heads are then manually calibrated and honed to meet exact tolerances and ensure a perfect fit with fasteners. Next, precision hole punching is done to create the socket openings on the ring ends. The semi-finished wrenches are then subjected to vibratory finishing to clean and deburr them further, ensuring a uniform surface texture. At this stage, the Alora logo and product codes are stamped into the body of each tool for branding and traceability. The wrenches are then zinc-plated to protect against corrosion, enhancing both durability and appearance. After plating, they undergo final manual finishing, where skilled workers inspect and fine-tune each tool for perfection. Finally, the wrenches are carefully packaged and prepared for shipment, ready to be delivered to professionals around the world. This rigorous process guarantees that every Alora wrench offers exceptional performance, long service life, and the trusted quality of German engineering. The hot forging press line 12,500 tons is a high-capacity system designed for producing large and complex metal parts under extreme pressure and heat. This line is widely used in industries such as automotive, construction, and heavy equipment manufacturing. The process begins with billet preparation, using high-grade alloy steels like 35 CRMO or 40 CR, which are cut to size and inspected for chemical composition and surface quality. These billets are then heated uniformly in induction furnaces to around 1,200 degrees Celsius to achieve the necessary plasticity for forging. Once heated, the billet is transferred to the press, where a powerful 12,500-ton hydraulic press shapes it into the desired form using custom-designed dies. The forging may involve a single or two-step process, including pre-forming and final shaping. After forming, excess material or flash is removed at the trimming station. Controlled cooling follows, using either slow or forced methods to prevent defects and ensure structural integrity. The entire process is automated with robotic handling, die lubrication, and temperature monitoring systems, ensuring consistency and productivity. Inline inspections such as eddy current testing and hardness checks maintain strict quality control, delivering durable, high-precision forged parts ready for demanding applications. The 12,500-ton hot forging press line not only ensures high forming accuracy, but also enhances material strength through the forging process, aligning the metal grain flow with the shape of the part. This results in superior mechanical properties such as increased fatigue, resistance, and toughness, critical for parts subjected to extreme loads or stress. The line is integrated with advanced automation systems for billet feeding, die spraying, part transfer, and real-time data monitoring, reducing cycle time and operator involvement. Additionally, it supports die change systems for quick setups, increasing production flexibility. With precise control over temperature, pressure, and timing, this press line guarantees high repeatability and consistent part quality. The forged components are ideal for applications such as truck and excavator track shoes, gear blanks, flanges, shafts, and heavy-duty connectors. Each step of the process, from billet heating to final cooling, is carefully monitored to meet international standards for safety, durability, and performance. The 12,500-ton line represents the pinnacle of hot forging technology, combining brute strength with digital precision, and is a vital asset for high-volume, high-spec industrial manufacturing. Forging bar refers to the process of shaping metal bars, typically carbon steel, alloy steel, or stainless steel, through hot forging under high pressure. The bars are heated to elevated temperatures and then deformed using a press or hammer, which refines the grain structure, eliminates internal defects, and enhances the mechanical properties of the material, such as strength, toughness, and ductility. Forged bars can be produced in various shapes, including round, square, rectangular, or custom profiles based on specific requirements. This process is widely used across industries such as automotive, heavy machinery, oil and gas, shipbuilding, and construction, where parts must withstand high stress and impact. Compared to cast or rolled materials, forged bars offer superior structural integrity, reduced porosity, and a longer service life. Their uniform grain flow and improved resistance to fatigue and wear make them an ideal choice for critical applications in demanding environments. Buffing is a critical step in the retread process that ensures the tire casing is ready for a new tread. After thorough inspection, the tire is inflated to its proper size and mounted onto an expandable hub. Buffing begins with setting the equipment parameters according to the tire specifications, including tread size, trim angle, and under-tread depth. Operators carefully buff the old tread off, starting at the highest point of the tire's crown and working towards the shoulders, ensuring even removal. Throughout the process, the tire surface is monitored for texture and depth to guarantee the optimal bonding of the new tread. After the buffing is complete, shoulder trimming is done to ensure a perfect fit. Finally, a pollution control system prevents excessive heat buildup during the process, safeguarding both the tire and machinery. Special attention is given to the tread depth to avoid potential failure or damage in the retreaded tire. This thorough process ensures a retreaded tire that performs reliably and lasts longer. Swapping shredder shafts usually takes hours, but not with this system. The Impactor 250 Evo features a quick change shaft mechanism that lets operators replace worn or specialized shafts in minimal time. A hydraulic lift raises the top cover, exposing the twin shafts. Once released, each unit slides out, and a new set slides in. No need to dismantle the machine. This setup boosts uptime when processing materials like concrete, wood, or metal, ensuring greater flexibility and less interruption in demanding conditions. In Brazil's sugarcane belt, the largest torque max ever built has been delivered to the 100-inch mill tandem at Usina Alta. Weighing over 90 tons, this industrial gearbox was manufactured in record time and is a key part of the plant's modernization strategy. The unit integrates Industry 4.0 principles, including real-time monitoring systems and enhanced automation. During assembly, heavy components were aligned with micrometric precision to ensure long-term performance. Once installed, it supports continuous crushing with high operational availability. Its robust design is engineered to withstand the extreme torque demands of large-scale sugarcane processing. This latest deployment marks another step into the era of digital transformation for Brazil's sugar industry. What it takes to bring a tire back to life. At this retread facility in Cleona, Pennsylvania, the process begins with initial inspection. Technicians examine each casing visually and electronically to detect hidden damage. Only those that pass continue to buffing, where the tire is reshaped to fit a new tread. In skeeving and repair, damaged sections are carved out and filled using specialized rubber compounds. Technicians are trained to recognize structural issues that aren't always visible on the surface. Cushion gum is then applied to the casing, acting as a bonding layer. This ensures a uniform surface before the new tread is added. During the building stage, a new tread is precisely aligned, measured, and stitched onto the casing. Any misalignment, even by millimeters, can compromise safety. Next comes enveloping. The uncured assembly is sealed inside a flexible envelope, vacuum checked, and prepared for curing. Inside the curing chamber, consistent temperature and pressure activate the bond between tread and casing, using the industry's lowest curing temperatures, allowing multiple retreads over time. After curing, the tire cools before entering the finishing area. Surface imperfections are removed, and identifying details are added for traceability. Finally, each tire undergoes a detailed final inspection. It's labeled, painted, and readied for shipping. Throughout the entire process, tracking systems ensure every tire meets customer specifications. By combining skilled labor and strict quality control, this retread line gives used tires new life, safely and efficiently. Bustling industrial setting, the installation of a steel warehouse structure unfolds with precision and expertise. Using powerful cranes, heavy steel beams are lifted and carefully positioned onto the foundation. The process begins with careful planning to ensure all components are in the correct sequence, followed by precise assembly. Expert riggers and crane operators collaborate closely, managing the weight and dimensions of the steel parts. Each beam is aligned to millimeter accuracy, and the structure's stability is continually verified during the process. Once the framework is in place, the team begins securing the panels and reinforcing elements. Safety measures are rigorously followed, with constant communication ensuring smooth operation. Environmental factors such as wind and weather are carefully monitored, ensuring no disruption to the process. The result is a robust steel warehouse capable of withstanding the most demanding industrial conditions, with a focus on operational efficiency and long-term durability. The project exemplifies cutting-edge construction practices and a commitment to quality. The R20-track maintenance machine takes shape through a fully integrated production process. The workflow begins with assembling the mainframe, followed by the installation of critical substructures, including lifting arms and track adjustment modules. Operators mount hydraulic systems and align track guides with precise measurement tools. Meanwhile, technicians install the power unit, electrical wiring, and control panels in parallel. Each step is carefully documented to ensure traceability and compliance with railway industry standards. All systems undergo initial testing on-site, fluid circulation, mechanical movement, and interface response, before the machine moves to calibration. Close coordination between engineers and production staff, made possible by the site's layout, ensures rapid adjustments during every phase. Final touches, like labeling, painting, and software updates, are completed before the machine is prepared for delivery. The R20's assembly reflects Swiss standards in reliability and accuracy, made possible by localized, synchronized teamwork. The backbone of naval defense. At BAE Systems, maritime operations combines skilled teams, cutting-edge technologies, and decades of experience. Shipbuilding, weapons integration, and platform support are carried out with precision across global locations. From submarine systems to radar and combat equipment, every component plays a vital role. Behind each operation stands a team committed to mission success, constantly adapting to future challenges and delivering operational advantage where it matters most. Remarkable engineering feat unfolded in Weinheim, Germany, as a new steam boiler system was installed at the Freudenberg power plant. This complex operation, captured in the video, showcases the intricate process of assembling a steam boiler system. The project commenced with the thorough preparation of the site, ensuring a stable foundation for the heavy components. A Liebherr LR 1600 crawler crane was assembled on-site to handle the massive loads. This crane, known for its impressive lifting capacity, played a pivotal role in maneuvering the large boiler components into place. The assembly process involved the careful coordination of various elements. Each component, from the boiler drums to the heat exchangers, was lifted and positioned with precision. The use of advanced rigging techniques ensured the safety and accuracy of the installation. Before major components were lifted, their dimensions and anchor points were verified against engineering drawings. Temporary scaffolding and access platforms were constructed to support workers during elevated tasks. Special lifting frames and spreader bars were used to maintain balance while hoisting asymmetric parts. To minimize vibration and structural stress, the team implemented controlled lifting speeds and synchronized movements. Weather conditions, particularly wind speed and direction, were constantly monitored to prevent hazards during the critical lifting phases. The logistics behind the operation were equally complex. Transport routes for oversized components were planned in advance, accounting for weight restrictions and turning radii. On-site, designated laydown areas were used for temporary storage, allowing components to be staged in the correct order. components were tagged and tracked through a digital inventory system, ensuring no part was misplaced during the staged assembly. Thermal insulation materials were pre-installed on some parts to save time during final commissioning. Flange faces were protected with covers until the sealing process to prevent contamination. Alignment lasers and digital inclinometers were employed to ensure angular precision between mounted units. Throughout the project, the team adhered to strict safety protocols. Regular inspections and quality checks were conducted to maintain the integrity of the installation. Radiographic and ultrasonic testing ensured weld seams met required strength standards. Protective gear and fall arrest systems were mandatory for all personnel working at height. In parallel with mechanical work, electrical installation crews began routing conduit and cabling to interface with the plant's control systems. Interface testing between new and existing infrastructure was performed to ensure seamless integration. Vibration dampers and expansion joints were installed at key points to accommodate thermal and mechanical movement during operation. To further optimize long-term performance, system diagnostics and pressure testing were carried out before final handover. Operators received technical training on system controls and emergency shutdown procedures. Digital monitoring tools were also integrated to enable real-time performance tracking and remote diagnostics. The collaboration between engineers, crane operators, and construction workers exemplified the synergy required for such a complex endeavor. All tasks followed a detailed work schedule that integrated mechanical, electrical, and civil engineering workflows. Upon completion, the new steam boiler system enhanced the efficiency and capacity of the Freudenberg power plant. This installation not only demonstrated the capabilities of modern engineering, but also underscored the importance of thorough planning and execution in large-scale industrial projects. In Hong Kong waters, a complex discharge operation unfolds as 3 jumbo derrick barges work in tandem to offload over 150 collapsed containers from a container vessel. These specialized containers, designed to fold flat when empty, optimize cargo space and return logistics. Their compact form, however, presents unique handling challenges. The process begins with the careful positioning of the barges alongside the vessel. Each barge is equipped with heavy lift derricks, capable of hoisting the folded containers with precision. Crane operators coordinate via radio to ensure synchronized movement and prevent any load imbalance. Once hoisted, containers are maneuvered onto the barge deck and securely fastened. Crew members monitor each lift, using hand signals and onboard systems to guide the alignment. The entire operation requires precise timing and seamless communication between vessel crew, barge operators, and support boats navigating the harbor. To streamline workflow, the team adheres to a pre-arranged lifting sequence based on container size and placement. Any deviation from the plan could result in delays or safety hazards. Weather conditions in sea state are constantly monitored, as even slight shifts can affect stability. Safety protocols are enforced throughout the process, including securing equipment and managing vessel positioning with dynamic mooring systems. The discharged containers are then transported to shore for storage, inspection, or redeployment. Witness the extraordinary transport of a 1,640,000-pound petrochemical splitter through Edmonton, Alberta. The massive piece of equipment is heading to the Heartland Petrochemical Complex under construction near Fort Saskatchewan. This petrochemical splitter plays a crucial role in separating propylene from propane, a key process in producing recyclable polypropylene plastic. The operation, captured at 12:10 a.m. on White Mud Drive at the 50th Street intersection, highlights the scale and precision required for transporting such heavy, complex equipment. Dacro Industries, the major contractor, ensures safe and efficient transport to the construction site. At the heart of global trade, container terminals operate with remarkable coordination. Massive gantry cranes lift containers from ships with precision, placing them onto waiting trucks or stacking them in designated zones. Automated guided vehicles transport containers across the yard, while operators monitor movement from control towers. Each container is scanned, tracked, and sorted based on its destination. Behind the scenes, technicians maintain equipment, ensuring minimal downtime. This synchronized workflow between machines and humans keeps goods moving efficiently through ports around the world. The pressure vessel, measuring 5.5 meters in diameter, is carefully loaded onto specialized transport equipment for delivery. During the journey from Himash, Bulgaria to Teknip, Italy, the vessel is secured with precision to avoid damage. This ensures safe and efficient transport, meeting all industry standards for pressure vessel handling. The Hyster H22 empty container handler is designed for efficiency in container handling at ports and terminals. This 200 model combines robust performance with advanced features to maximize productivity. It features a high-lift system that allows for easy stacking and retrieval of containers, even in challenging environments. The precision control system ensures smooth operations while reducing wear and tear on the machine. With its reliable lifting capacity, the Hyster H22 is built to handle the demands of heavy-duty container handling with ease. The MV Svenja embarks on an impressive voyage to transport 8 Daman tugs and an e-house, showcasing expert planning and precision in logistics. Starting in Vietnam, the ship loads 6 tugs in Haiphong and 2 more in Da Nang. The tugs, weighing up to 500 tons each and measuring up to 28.6 x 14.4 x 15.8 meters, are carefully secured on deck with specific placements for safe loading and unloading. A lifting arrangement is created to ensure the e-house, weighing 1,250 tons and measuring 22 by 28 by 23 meters, is safely loaded amidst the tugs. Once the tugs are loaded, space is reserved for the e-house, which is the last to be loaded in Batam, Indonesia, and the first to be discharged in Rio Grande, Brazil. The voyage concludes with the delivery of the tugs to their final destinations in Lagos, Nigeria, and Rotterdam, the Netherlands. This operation exemplifies the thorough coordination and heavy lift capabilities required to transport large, complex cargo across long distances. A heavy industrial boiler is loaded into a shipping container using a pair of powerful forklifts. The process starts with a large forklift, lifting the boiler and carefully lowering it onto the container base. Once positioned, a smaller forklift arrives to support the final alignment. The two forklifts are then connected, forming a combined unit that pushes the heavy boiler fully into place. A mechanical coupling system links the forklifts, allowing them to operate in unison during the final push. This cooperative setup allows for precise movement and controlled force, essential for handling such a massive and delicate object. Operators communicate constantly to ensure balance and safety throughout the process. This operation highlights the specialized equipment and teamwork required to move oversized industrial machinery into tight shipping spaces.